Good morning, everybody. It's John Pendleton. I'm your trainer today, and we'll give just a few more minutes. Make sure people can get signed in. We'll get started probably about 5 after 9. So we'll get started here in just a few minutes and learn a bit about troubleshooting the ECMs. Thank you. Good morning, everyone. John Pendleton here again. We'll go ahead and get started today. Not a real long webinar, maybe half an hour or so. Just going to go over some ECM fan troubleshooting stuff. In this video, I do have kind of like a little flow chart or not video, but webinar, a little chart that I'm going to show, as well as it's going to show basically where the pin designations are. And if that's something that you'd like to keep on your truck or something, at the end, I'll have my email address. Shoot me an email and I'll send you over that troubleshooting chart for the ECM. And again, it'll have like the low voltage 16 pin harness, and it'll show all the different pins and what call is related to those, so you can do some troubleshooting. So it's always a good thing to have on your truck. And it's pretty universal throughout the industry on those harnesses. So, you know, if it's a Lennox unit or a Carrier or something like that, it'll probably work for those as well. So if that's something that you'd like, again, shoot me an email. Again, this webinar is recorded. So later on this afternoon, it'll be uploaded to our YouTube channel, which is Enertech University. And you can subscribe to that and I'll let you know when we got new videos. But basically, we record all the webinars now, so you can go back and watch them at a later date. I apologize. I was muted. I apologize for that. Let me run back real quick. I apologize for that, Curtis. I thought I had unmuted, and I must have already been unmuted and remuted myself. Sometimes I'm not the most tech or computer savvy person, so I'm more of a service technician. That's where my background comes from, so I apologize. Basically, let me go back real quick and so you guys can hear what I said here. Basically, there's two issues with the motor that doesn't run or it does not change speed. And basically, on the end bell of this picture here is the module. It's kind of like the black piece, and then you have the motor. Now, when we replace, if the module fails, we replace the motor in the module. If the motor fails itself, we replace the motor in module. In the past, we used to be able to just change the module and order just a module, and the price was pretty expensive. I don't know, it was $300 for the module and $300 for the motor. So it'd be about $600 for both. Now it's around $300, I believe, for both of them combined. So the price has dropped, and we do not have just the module. It'll be the module and the motor. Now, I'm not saying that you couldn't just change the module if the motors are the same. You're more than welcome to do that and maybe just keep the motor for future use or something. And I would probably just go ahead and replace just both of them if it was me. But if it's in a tight area where you can't get the motor out or something like that, you can just change the end as long as they're the same manufacturers. But basically, either the blower's not going to run or it's not going to change speeds. So if the blower does not run, basically what we're going to do is we're going to check voltage between the transformer and common on the ECM board. If you look at the ECM board, and we'll show one here in a minute, there's a little fuse, little 3-amp purple fuse on that board. And that's really our only fuse in our low voltage circuit. Right next to that is where your transformer, your secondary voltage from the transformer comes in to the unit. So the first thing we're going to do is make sure that that transformer is sending power into the unit. Now, you can also look on the lockout board, and the lockout light's flashing. We're pretty sure we've got voltage, low voltage, into the unit itself. Obviously, if there's no power, low voltage power on the secondary side of the transformer on the ECM board, then we're going to want to check the primary transformer power. Make sure it's 208 or 230, and make sure you've got it wired into the proper tap on the transformer. Most of our units are going to come from the factory wired for the 230 volt. So if you have 208, make sure you switch that around. It can cause some other voltage issues. Just make sure you got your primary voltage coming in. If you do have voltage and the breaker on the little resettable fuse on the transformer is not tripped, then obviously the transformer is bad and we'll have to replace the transformer. If you do have secondary voltage or voltage on the secondary side of the transformer, go ahead and either jump her out or turn the thermostat fan switch to the on position, or you can jump her out G and C on the terminal strip, or G to R, I'm sorry, and see if you have voltage on the ECM board screw terminals at G and C. Obviously, if you don't have any voltage there, check your thermostat wiring. Your thermostat, you may have to be replaced. Whenever these blowers see a call, they're always going to need to see that G call with it. So if you've got a cooling call, it's going to have a G as well. It's going to have a Y1, a G, and an O from the thermostat. Same thing in heating. If you've got a heating call, you're going to have a Y1 and a G. That's why if you ever call into tech support to try to diagnose one of these, we always have you just check between the certain pins, which is 1 and 15, but that's the G call. So we want to make sure we've always got the G call. If we don't have a G call, but let's say we have a Y call, Y1 call, the blower won't run properly. It's got to see that G call. So if there's voltage between G and C on the ECM board, then on that board, there's a 16-pin harness. And here on the right side of this picture of this slide here is that 16-pin. So, and you can see that with the clip on the bottom, if you've got the harness from the blower motor in your hand, the wires coming out, that's what we're looking at. The wires coming back at you. So the holes where it plugs into the board are on the opposite side. So the wires coming out, you're going to be looking at. 1 is going to be on your lower left, and it's going to go 1 through 8 on the bottom, and then 9 through 16 on the top. Now, 1 is common. It's normally a blue wire, so you can kind of figure out where number 1 is based on that color of that wire. Now, I say it's a color, but I have seen some old train units and things that had all black. So you do have to go by the actual, where it's located. But ours will show number 1 as the blue wire, and then 15 is on the top, almost all the way over to the right, 1 over from the far right, and it's normally a green wire. It may be a green with a yellow trace on it, but it'll normally just be a green wire. And so you can turn the plug around and put your meter leads in there and check for voltage. You've got to have at least 14 volts to the module for it to realize that there's a call. Now, normally it's going to be up closer to that 24 volts, but if for some reason your transformer is a little bit weak, it's got to see at least 14 volts. So with the unit calling for a G call, if you have no voltage between pins 1 and 15 on the board itself, then the board is obviously bad. Now, I will say this, that these ECM boards are very reliable. I'm not saying that they don't fail, but very rarely do we have an ECM board that's bad. It's really a board that's used throughout our industry. We're not the only ones that use it. And it's been around for a long time, and it's super reliable. So I'm not going to say that the board is more than likely not the issue, but I don't see it very often. Let's put it that way. If you do have proper voltage at pins 1 and 15 coming out of the ECM board, then reattach the 16-pin harness to the board and go to the blower motor and unplug it from the blower motor. And then check again with the call for G, check at pins 1 and 15 on the harness at the blower motor. Make sure we're getting power through the harness. There could be a short in the wire. Sometimes the Molex plug, the pins don't get pushed in there all the way. I've seen that on brand new units. Sometimes the Molex pin does not get shoved in that hole all the way. So make sure that those are all snug in there. You can't pull any of those wires out of the Molex connector, and check the harness. Like on an XT or a CT unit, so a combo unit or the older packaged unit, there's another Molex connector in between the control panel and the unit itself. And we kind of eliminated that because we did have problems with that Molex connector between the control panel and the unit. So make sure that those are tight as well, because there is another connection point on the combination unit and the older XT packaged unit. Obviously, if we don't have voltage, low voltage down to the blower through the harness, then the harness would be bad. We've got it at the board, we're just not getting it, through the harness. So we would just have to replace the harness. I've seen that a few times. We've had to replace it. But yeah, if you're not getting it down to the blower, then the harness is bad. If you have proper voltage at pins 1 and 15, then we know that it's usually getting a call. And some of these ECM motor modules have a little black box on them. Some of them don't, just depends what series you have. But there is like a little green and red light that'll flash rapidly on those. And I can't really tell you what the flashes necessarily mean. All I can tell you is if it is flashing, it's normally telling it that it's trying to communicate. Now, it doesn't necessarily mean that it's accepting that communication, but it is getting communication from the board. So if you do see some flashing lights, that's usually a pretty good indication that we've got low voltage down to the module. Again, if you have voltage down to it through the harness and it's not running, then the module is bad. One very good indication that you have a bad module, if you ever open up the blower compartment and the blower wheel is kind of rocking back and forth, then what's happening is that ECM is trying to communicate and it's not getting the signal and it doesn't know which way to turn. And so it's trying to find direction or rotation. And so if you ever see one just kind of shake back and forth, the module's bad and it'll have to be replaced. So if the low voltage checks out, you're getting voltage down to it, we want to make sure that we check the high voltage as well. Obviously, if we're not getting high voltage, then the blower is not going to run at all either. So we'll move on and check the high voltage. There's two harnesses on that blower motor module. There's a 16 pin for the low voltage, and then there's the high voltage, which is a 5-pin harness. We're only using 3 of those. You've got a ground and then your 2 power legs. So 1 and 2 are not used. So obviously check for 208, 230 volts between L1 and L2 on your contactor. Now the ECM blower, the high voltage, there should always be high voltage to the ECM blower motor. The low voltage controls the signal and the high voltage is present all the time. So make sure that it's wired in to the L1 and L2 side of the contactor and not the T1 and T2 side of the contactor. If it's on the T1 or T2, maybe it could be miswired from the factory or something on a new install, and it wouldn't get any power until the contactor closed. So we normally would just have high voltage to it all the time. Obviously, if you don't have power to L1 and L2, then we need to research why we're not getting power to the geothermal unit. So, the breaker in the home's panel, make sure the breaker's good and not tripped there, and that there's nothing wrong in the power wires coming from the breaker box. If you do have voltage present, go ahead and remove the high voltage harness from the motor module and check for power there. If you don't have power to the high voltage harness, then obviously there's something wrong with that harness as well. Again, it's a Molex connector with some pins. Make sure those are snugly in there and that they're tight at the contactor and any other points that make connections. If all those are good and you still don't have power out of the harness, then the harness is bad and we'll have to replace the harness. If you do have power to the motor, you can dig in a little bit deeper if you'd like. It's probably not necessary at that point. We know that it's getting high voltage and low voltage, so there's obviously something wrong with it. But if you're like me and you want to know, well, is it the motor or is it the module? Do we have a high voltage or a low voltage issue? You can disconnect the power to the unit and wait about 5 minutes. And then you can remove the module from the motor. There's some capacitors in there that will hold power. So if you don't wait the 5 minutes, the power could still be in those capacitors and you could get shocked, and that's never a good thing. So if you wait about 5 minutes, it'll drain that power out of those capacitors. After you've removed the module from the motor, there is another Molex connector inside between the motor and the module, and you can disconnect it and you can ohm out the windings on the motor and check to see if they're internally shorted, or also you can check them to ground. If it's shorted to ground, obviously the motor is bad as well. Again, wait the 5 minutes. That's super important. It's just not fun really to get hit. You can see in this picture here, there's like a red and green wire. That's the wire that'll plug in, and you can just remove it from the module itself, and then you can ohm out those two windings across each other, and then also ohm them to ground. Now here in the picture, it showed red and green. I do believe that they're normally a red and blue wire, and you can measure the ohm windings. They should be within 10% of each other, and normally less than 20 ohms. Now, for some reason, the motor is super hot, like it went into internal overload, then you're probably going to get a really high resistance. So that's going to be a pretty good sign. Grabbing a hold of the motor and feeling it and seeing that it's hot is also a pretty good sign that it's probably seized up. Again, measure at the ground. Any resistance in the motor is shorted. So anytime it shows resistance to ground, then there's a direct short to ground. A good motor will show infinite to ground, so it'll show, on my meter, it'll say like OL. If it shows OL, then it's not shorted to ground. If it shows resistance, 0.1 to ground or 1.0 or any kind of resistance to ground, then it's shorted to ground. So if you take it to ground and you see OL on your meter, then it's not grounded. This will be a good reading here to ground. You can usually take it right to the motor itself. After you take off that module, there's a non-painted surface. So you can usually just use that as your ground. But that would be a good reading, and that would be a failed reading. Excuse me. If ohm readings are bad, replace the motor in the module. If the ohm readings are good, but the fan still does not operate, the module's bad. Again, replace the motor in module. There is a training video online already on YouTube as well that'll kind of walk you through how to check the ECM. Again, in this picture, you can see that when the harness is plugged in, it's actually kind of upside down. So 1 is actually in this picture in the upper right corner, and number 15 is in the lower left corner there. Yes, Curtis, if you shoot me an email, I can send you the, I'll send you a PDF of these PowerPoints today. And yeah, you're more than welcome to have those and look at them. And in any of my trainings, you're more than welcome to shoot me an email and I'll send them out to you. That's definitely not a problem. We'll just send you the PDFs of it. So it looks like I don't, let me see if I can't find that troubleshooting chart here real quick. Let me see what we got here. Let me see if I can't find that ECM troubleshooting chart here real quick. Oh, I'm not tied into the office right now, so I can't really pull that up. But if you shoot me an email, I will. We have a flow chart basically of the ECM troubleshooting that if you want the PowerPoints, I'll definitely send that along with it. So let me, here is the contact information for tech support, as well as my email address and the technical services email. So you can jot down my email. If you got my card, you can call me as well. But just shoot me an email. I'll send you the flow chart as well as the pin designations for the ECM, the different terminals. That way you can keep that on your truck. I normally keep one in my little bag that I go to site visits and stuff too, because I can't remember them either, and I don't expect you guys to. There's so much to try to learn and know that it's hard to remember everything. So shoot me an email. I'll send you that little troubleshooting flow chart for the ECM troubleshooting, as well as the pin designations. And then if you want the PDF files and the PowerPoints, I'll definitely shoot those over to you. So if you shoot me an email this morning, I'll get back to you pretty quick. Probably have it by this afternoon for you. So if you have any questions, feel free to ask. And we'll kind of go from there. Keep checking our secure site, the Enertech USA.com or Enertech University, and I'm going to be putting up probably some more trainings maybe tomorrow or Friday. We've got a training next week already scheduled, and then I'm going to try to keep doing the Wednesday webinars. If you guys are looking for more webinars, again, shoot me an email. Let me know what you want. If you want longer webinars, shorter webinars, more one-on-ones, just anything. With online trainings, there's a lot more open up to us now. I don't have to travel so much. I'm in the office more, so I can do more training. So if there's something that I've done and you want to, rehash it, shoot me a message. I've got the time to be able to train you guys. So definitely reach out to me. I really enjoy doing the trainings, and I hope you guys enjoy them as well. So again, thanks for joining today. And I look forward to talking to you guys soon. Thanks, and have a great day. You're welcome, Chris. Have a great day.